Hello and welcome back to Code with Vinay. Some time ago, I posted a video titled Food for Thought Number 1. The video posed a problem on factorians, also called special numbers. Factorian is a natural number that equals the sum of the factorial of its digits. For example, in base 10, 145 is a factorian because 1 factorial plus 4 factorial plus 5 factorial equals 1 plus 24 plus 120 equal to 145. The problem was to write a program to find out the number of factorians in base 10 in the entire range of integers. We also developed a simple solution in the last video which was correct but failed to give the answer in a reasonable time frame. In this video, I'll tell you the solution to that problem. Ideally, for continuity, you should watch this video after the previous video. I've shared the link to the first part in the description below. So in this video, we'll modify the program developed in the first part so that it gives the output in a reasonable time frame without waiting for too long. Now there are two places where we can perform some optimization. We will begin with the simpler optimization. The first thing which you must notice is that we are using the function getFactorial to compute the factorial of a number, and this method is being called numerous times to compute the factorial. However, there are only 10 digits for which we need to compute the factorial, and if we store the factorial of those 10 digits in an array, then there is no need to compute the factorial again and again. Since we are running the loop for the entire range of positive integers, that is from 1 to 2 to the power 64 minus 1, the repetitive calculation of the factorials is wasting a lot of time. We will first create an array of size 10 to store the factorial of 10 digits. That is, we'll say private static int factorial. We'll make it an array and we'll say that the size of this array is 10. Our next task is to create a function to initialize the array factorial with the factorial of the 10 digits from 0 to 9. So let's create the method. We'll say public static void populate array, because that is what we are doing. We are using this function to populate our array factorial. Now, the first two factorials are fixed at 1. Factorial of 0 is equal to 1. Factorial of 1 is also 1. So we'll say factorial of 0 is equal to factorial of 1 is equal to 1. And now we'll populate the remaining array, that is from 2 till 9. So I is less than equal to 9, I plus plus. And then we'll say that, okay, factorial of I is equal to factorial of the previous digit, that is I minus 1 into I. And this will populate our factorial array. Now this populate array method needs to be called right at the beginning before we do anything else. So we'll go to the beginning of the getFactorian count function and we'll call our method. Now we don't need the getFactorial method because we have all the factorials already stored in the array. So we'll remove the method, and where we are calling the getFactorial, we'll replace it by simply reading the array. We'll say factorial of temp modulus 10. These steps take care of the optimization to prevent repeated calculation of factorial of 10 digits. Our next optimization will drastically reduce the number of checks we are making for the entire range of positive integers. That is, we'll now try to bring down the loop from integer.max value to some lower value without compromising our objective of finding the positive factorians. Let us first explore this in some detail. The sum of the factorials of an n-digit number can't exceed n into 9 factorial. This is because the highest single digit is 9, the factorial of 9 is 9 factorial, and n such factorials will be n into 9 factorial. An n-digit number is at least as large as 10 to the power n minus 1. Convince yourself. For example, for a 2-digit number, n is equal to 2. 2 minus 1 is 1 and 10 raised to the power of 1 is 10, which is the smallest 2-digit number. Now, n into 9 factorial is n into 362880, which is the value of 9 factorial. So, from this discussion, we can conclude that for a n-digit number, n times 362880 is less than 10 raised to the power n minus 1 is less than the maximum factorial. Now, this expression only holds for values of n up to 7, and therefore, the factorial cannot exceed 7 into 362880 or simply 7 into 9 factorial. This implies that the upper bound of a loop can be just 7 into 9 factorial instead of integer.max value. Now let us implement this in our program. So now we know that our limit is 7 into 9 factorial. So we'll say limit is equal to 7 into factorial of 9, and then instead of integer.max value, we'll say limit. Now let us run the program to see how many factorials are there. So now if we run our program, the number of factorials is 4. And our program is finishing almost instantly. That is, we are getting the result in reasonable amount of time. In case you are curious that what are those 4 factorials, then we can simply print them. That is, over here, we'll remove this line first, and then we'll add a print statement as well. We'll say system.out.println I. And if I run the program again, it will show us the 4 factorials along with the total. So let's run it once more. And there we are. The 4 factorials are 1, 2, 145, 40585, and finally we have the count, that is 4. That's all for this tutorial on how to find the number of factorials or special numbers in base 10 for the entire range of integers. I hope you found this helpful. See you in the next video. Till then, happy coding. Your feedback is valuable to me. I want to make sure that my videos are clear and helpful. You can follow me on the internet on any one or all of these channels.